we've kind of been talking a little bit about non-motor branch circuits. We said receptacles 180 VA, and we talked about lighting being based on what the load is. Motor loads are based on horsepower, and the associated disconnects and such are also based on horsepower. I guess I didn't say for motor loads one thing or one reason why the code would allow you. We didn't really discuss that I'm arbitrarily saying we know the transformer and the motor will have higher current at the start, so we're gonna just set the circuit breaker higher. That sounds reasonable, then it won't trip. But then what about when it's operating normally? We want it to trip then too. And so it is just a difference from the motor branch circuits. It's a little less concerning about the concept of spending too much money in the project by deciding to go for that 250%, if that's what Article 430 in this case of the code would allow you to do. And the reason is because there's thermocouples on motors, meaning they're basically heaters that are help to make sure for overcurrent that there would be a disconnect locally. It would disconnect locally. So, but in horsepower is how. So you could have a 1 horsepower motor, which might be equivalent to 745 watts of power. However, there's efficiency of the motor as well, and necessarily power factor is a part of it too, which we really haven't talked about here or have time to. So it's rule of thumb to say that 1 horsepower is equal to 1,000 watts, 1 kW of, or maybe kVA, you might rule of thumb that way. And we're talking about in high level load estimating, not in when you're at the construction level document, right? We're just, yeah. Okay, so when we're doing furniture layouts and stuff, we might be coordinating with architects for layouts because you have to get the circuits to it. So floor boxes and power poles are not very attractive. Usually these are also have AV elements, so you might have data cables or communication cables in them. And with regard to the lighting, a large subject is the lighting control. So lights can be controlled just line voltage, which just means when you flip the switch, you're literally breaking a circuit like this. There can be single pole or three-way switches. The three-way switches, if you had to have 2 switches and one of them turns off, one of them turns on. If you start to have lots of switches or otherwise, there's complications in this. That starts to be a low voltage solution is a better way to go. Usually it's less expensive. You just bring power to all the lights and then have a low voltage switch, turn a relay power pack off and on to get that with a smaller wire that you don't necessarily have to put in conduit. You might be able to route it differently and save money in the installation, and also get more functionality out of the digital push button concept, or for dimming, that might be even a more effective way. Emergency lighting becomes a real topic for lighting and lighting control. That's probably the harder or more complicated aspect of making sure that that is, and again, we prioritize life safety, so paid attention to. Okay, I'm gonna turn this stuff blue. I'm sorry, black. I'm looking at the time and I see we have about 8 minutes before I want to open it up to make sure we answer questions. So let's see. Okay, we have been talking very specifically about motor branch circuits. The only thing here I'll say is there's an AIC rating, or the interrupt rating. And so that part is one when you have lots of, that motor controllers should be considered of what that will be. Consider what the fault current will be there. That's the fault current. What happens if there's something, wires that touch ground or themselves or otherwise a fault, a reason to have overcurrent protection work. The equipment, you don't want it to explode before the overcurrent protection can work. So there's AIC ratings, all the equipment, and that's especially one that we're probably more guilty than others that not really coordinating that well. The idea of putting fuses in front of them used to be okay, but or they call it the up and over method, but it can be a questionable practice. All right, let's see. So I'm going to continue and talk about electrical rooms. So in chapter 1, you can see that here. This is, it would have otherwise been a 400 for a table in the NEC. But this in chapter 1 talks about the working clearances, and it depends on what's in front of the panel and what voltage it is. If it's nothing in front of the panel, the voltage under 1,000 volts says it just needs to be 3 feet clear. If there is a grounded part, such as a grounded wall panel or otherwise piece of equipment that's different, or if there's other equipment in front, that's also different. At medium voltage, that would be a different case too. But all of the equipment clearances, the width is, I believe it's a minimum of 30 inches, or the width of the equipment if that's wider, and then it's 6.5 feet in front, and then you know, about a little bit taller than the person, that about range, and then 6 feet above the footprint of it, and then you can't have stuff over the top of that, or in that range. We kind of avoid anything over the top of electrical panels. Fire protection could be an exception, but we still in general try not to do this. Any questions about electrical rooms? I know I skipped over this. I'm just not sure we're going to be able to hit it specifically. Okay, grounding and bonding. I think we said that already. That isn't something we're going to be able to talk a lot about, but definitely a question we will attempt in the QA at the end here. Fire alarm systems may or may not be needed for buildings. There's initiating devices and audio and visual appliances. So you need to locate where pull stations are, such as at exits, and it's within a distance from that exit that it's required to be. Where smoke detection, and this really starts to be the building code. So NFPA 72 specifically for fire alarm, that's not the building code, but the building code itself is depending on the occupancy, something that you really have to look at heavily for fire alarm to start off the conversation of what is the appropriate design. Fire alarm systems can also have voice evac type functionality, and in some cases is required. And again, that's pushing to the building code conversation. The aspect of a fire alarm in general is what you're trying to do is get people out of a building. So there are some buildings that people can't do that. They can't self-preserve or and so the occupancy classification and how the fire alarm system's reporting makes a difference. Okay. I'm going to slide down to, because this is talking about technology rooms. So this is sizing of those rooms and where they need to be located, which is normally within a 200 and about 50-foot radius, because there's a maximum cable distance. And you have to consider the up down of that cables as well, and the bundle. They normally have at least a little bit of bundle at where they're terminating. So this is a description or otherwise trying to help demonstrate that they technology rooms happen in the buildings. These are other special systems, you may call them, or otherwise low voltage systems that are common in buildings that more and more we're needing to design to or have special teams designed to.